So it may come in and we will compress it and we will do a cold rolled steel or a hot rolled steel and we get it to the shape that we want. It's a lot more ductile, easier to do that and to get, especially for mild steel products as well. Okay? If you have a high carbon surface, it takes a lot more force and a lot more wear and tear on a piece of machinery as well. Okay? Environmental progress in the steel industry. Air quality greatly improved since 1970. Discharge of air and water pollutions reduced by over 90%. And they're still fighting, I shouldn't say fighting, they're still trying to improve this. Okay? They're making great strides in terms of recycling. Alright, let's look under metalworking processes. Out of the book, page 69. I'm not going to read out of the book yet, I'm just going to be off of the PowerPoints. Excellent. Okay. I want you out of the book to look through this on your own. I'm going to talk about this a little bit off of the PowerPoints. Okay? So, metalworking process, they can shape it and improve its characteristics by forging or by rolling. Okay? Compressing it, slag, so forth. I will find a video to link to the Blackboard page as well so that you can see this. Destroys the cast structure. It gets the grain structure to orient the same. Makes a stronger steel, more ductile steel, and a greater shock resistance. So let's talk about that real quick. Okay. So what happens? Okay. What happens is it's poured into an ingot. So this will be a side view. Let's just say that it's set this way, poured into a big iron ingot. Your grain structure might go this way because it was poured in different layers, okay? So your grain structure is going all sorts of different directions, okay? What they're going to do is they are going to put it through a series of rollers, okay? When it comes through, and they're going to do this several times, and they're going to orient the grain structure to where they slowly all fall in to the same piece, or to the same direction, okay? This is a much stronger steel. If the grain structures are lying in the same direction uniformly throughout the material, it is a much stronger steel than this was, okay? So we got added strength, added impact resistance, tighter grain structure, easier maneuverability, and not necessarily ductility. Ductility, it is a higher ductility or a softer material in this form than it is in this form. Okay, so hot rolled, especially cold rolled steel, higher strength, less ductility. Okay, they're directly proportional in the opposite direction. Well, it does say it gives it more ductility. But anytime you make it stronger, you usually lose ductility. Forging. Forging is a method of reducing metal to a desired shape. It's not necessarily done by rolling, as it is by hammering. Okay? So, you, instead of rolling it through hydraulic rollers at 100 thousandths at a time, you're taking it and you're physically, just like old school blacksmithing, you're pounding it together, okay? Most of them today are done with hydraulic presses or electric. Still primarily hydraulic because the uniform pressures we can achieve by fluid power systems is really high and very consistent, okay? Drop forging is a piece of roughly shaped metal placed between die-shaped faces of an exact form or finished piece. The metal is forced to take form by drawing dies together. Many automobile parts are this way. So you got it set into a piece, a tool and a die, so to say. You put a piece of material in there, and then, so let's just say, we don't have to do it top and bottom, let's just go this way. So our piece of material may be set in here like this, okay? You'll bring it in, and then you will press it in there nice and tightly to press it in. And this is how most automobiles structures are done today. So we've got a piece of material here, and as we press it in, it takes shape and form of the die itself. Then we release it, it is in that shape, okay? Rolling. Steel rolled hot except for finishing passes. After rolling, the ingots are known by size and shape, whether they're a bloom, billet, or a slab. Excuse me, a bloom, square or oblong with minimum cross section 36 inches. A billet, square or oblong but smaller than a bloom. And a slab, oblong and varies in thickness from 2 to 6 inches and in width from 5 to 6 feet. Easy way I kind of remember this is this would be a large piece of round stock. This would be a small piece of like 2-inch square stock. A slab is basically, for me to help remember, it's basically in the shape of like a plate, ununiform plate material, okay? Samples of various shapes produced by hot rolling. We can see we've got square tubing, whether it be square bar, full bar, or round bar. Ovals, different sections. This is square, even though its configuration is in a diamond. Look at, here's channel. Here's how channel started out. This is fun to see because it starts out as a rectangular piece. It's flattened out, and then what they do is they start drawing or rolling it through a set of rollers. Now look right here. So they've got the channel built, okay? But it's not, it doesn't go through to perfect uniformity like this. So what happens is we get distortion and we get stresses as we start rolling and moving these things, okay? So we draw it out to the correct dimensions that we want, and then our last piece is we get it to the correct dimension, so then it won't spring back, okay? You're making it out of shape at first, and then towards the very final passes is where you bring it to the final finished shape, so there's less movement at that point, okay? It helps remove some of the residual stresses as well. Okay, we're going to read through the PowerPoint here as well. Processes for rolling steel. This is all in your book, but I'm just going out of the PowerPoint for now. Okay. 1/2 of rolled steel products in the U.S. are flat rolled. Includes plates, sheets, and strips. Hot rolled. Hot rolled is finished at temperatures between 900 and 2400 degrees. Okay. Look at cold rolled. They're finished at room temperature. So anywhere from 70 to 100 degrees roughly. Okay. Or Most places are going to be 70 degrees, especially in a steel mill. This is black iron. This is usually coated with a zinc or a galvanized tin plated or something on the top. You'll notice that what we weld on in the shop is usually a hot rolled steel. It's less expensive. It has a thin layer of oxide on it still, and it's got a much rougher, coarse grain structure. The cold rolled is a much shinier surface, and the grain structure is much more fine and flattened out, almost like a mirror finish, so to say. Okay? So the difference between this has less strength, this usually has higher strength. Okay? They're classified according to the method of manufacture, welded or seamless. So, metal pieces are heated until the surfaces are put together, and then they're forced together to kind of bond. All right. Seamless means that they're heated steel bar pierced by mandrel and rolled to desired diameter and wall thickness. So, for example, a piece of pipe, okay, you can have DOM, which is drawn over a mandrel, or seamless pipe. Rolled pipe with a seam in it is usually started in a plate. It is worked to where it's in a surface like this, and then depending on the manufacturer, it's either has a weld down the center or they are heated up, created heat, and then once they're really, really hot, they're forced together, held there to solidify while they weld and be fused together. Okay. This, as you can imagine, if it's under a high amount of pressure, the seam is going to be your weak point. All right. So many high pressure steam lines and so forth are usually designed for the seamless type, to where you have a solid piece of material that is drawn and rolled over basically a mandrel that goes in the center of your pipe, and the material is formed on top of it. Okay. It takes more work to create seamless pipe, therefore it is a higher cost as well. Okay. Here's a good example of piercing. Quite a process. Goes from squared around up here on the top, cut the length, brought back through, then you reheat it, come through, you can center punch it, roll it back through, so here's your center pieces, brought in, sizing rolls, so forth. Alright, structural steel shapes. Structural beam, I-beam, C-channel, angle iron, unequal leg angle iron. This is equal leg, so both the legs are the exact same size. This one, the legs are opposite sizes. Railroad, U-bar, a T, and a Z. This is looks very similar to a purlin that most of us have used in construction. However, there is a little bit of difference within the variation, okay? This is a good example on the metals preparation course of which piece is the web, which piece is the flange, so how is the structure designed. Steel may also be shaped into wire, bars, forging, extrusions, rails, and structured shapes. These are just a few of the basic steel shapes with which welder fabricators work. My dad, I was born in Ohio. My dad spent a lot of time driving truck from the steel mills to up to the car mills in Detroit, the car manufacturers. And a lot of them were rolled off into various sizes of round wire. So you could have a 2-inch round wire, and they would come in on a big roller, and they would come through, they'd unload them, and then they could set them in there and start pulling them into basically just like this, and then rolling them through a set of rollers, flattening them out and getting the correct shape that they wanted to be rolled or forged into. All right. Okay, rolling directions. Remember earlier, I pulled this up, it's still underneath here. We talked about trying to get the grain structure to go the exact same way so that we increase strength, increase ductility as well. So there's 3 different rolling directions here. We look at the axes this way. We always place the x-axis in the direction of rolling, okay? So if we're looking down a long piece of material, that is the z-axis, that's the direction it would have been rolled and flattened. The y-axis comes across the center, and then your z-axis is the thickness. Most of us are picking up on this by now because it's very similar to anything we do in machining as well. If you notice, most of the trade systems are very uniform in the way that the terminology they use, okay? So, number 1, X has the greatest strength and ductility. Coming across this in a Y direction, you have 30% loss in strength and ductility, and then Z is the lowest. Naturally, this one can fluctuate different because due to the thickness of material as well, okay? So if you were to ask which direction has the highest strength and ductility, this is a bulleted item. The X direction with the direction of rolling would have the highest strength and ductility. Z would have the lowest strength and ductility, the through thickness section. Okay? Drawing. Okay. Read through this one on your own. It's not a lot that you see. This is kind of, we're talking about drawing a piece of wire out, doing so forth. It can be associated with a lot of things. Length of the metal bar, the wire. So you're not adding material. You are basically just increasing length by rolling it out and keeping the same diameter and just drawing it out, okay? Extrusion. Extrusion can be forming by pressing through an opening, so forth, okay? Cold working. Shaping of metals by working at ordinary temperatures, all right? Methods can be hammered, drawn, or rolled. Typically below 500 degrees is what cold working is considered, okay? Heat treatment. The heat treatment, I want you to go to page 71 in your book. Right-hand column underneath heat treatment, highlight heat treatment. It says it's the process of heating and cooling a metal for the purpose of improving its structural or physical properties. Very often this is done to remove stresses caused by welding, casting, or heavy machining. Through various processes of heat treatment, we can make a metal easier to machine, draw, or form by making it softer. Or we can increase the hardness so that it will have wear resistance. Okay? So, back here real quick. Look right here in the center, and we are back to reheat properties. Okay? So it comes through, we do it in the initial shape, we reheat it, kind of stress relieve it, and then we start working it back around again. Okay? Here's where we're going to take a break. We're going to start talking about the differences within heat treatment. So when we come back, we will start on page 71 and continue forward, okay?